Assalamu alaikum students. Today our topic is related to electrical resonance in LCR circuit. Lastly, we found out that in case of LCR circuit, we're having Z, the impedance. What do you mean by impedance? The total portion offered by LCR circuit to the flow of current. That Z equals to V over I equals to under root of what? R square plus XL minus XC whole square that we read lastly. Now today we have to read about the electrical resonance. Electrical resonance is said to take place in LCR circuit, in series LCR circuit, when maximum current is allowed in the given circuit for a given frequency. The maximum current will only flow when we will be having what? When the capacitive reactance maximum current flows in LCR circuit only when capacitive reactance is equal to what? Inductive reactance. And both are equal, then we will say at that very time there is electrical resonance in the circuit. And when the electrical resonance is in the circuit, then these two very terms are equal, then the total resistance of the circuit that becomes equal to the R. And at that very time, when we are having only, although we are having inductor in the circuit, although we are having capacitor in the circuit, but we are having only the resistance of the resistor. At that very time, the resistance is set to take place. The frequency, the frequency at which resonance take place in LCR circuit is known as resonant frequency, and this resonant frequency is denoted by what? It is denoted by nu naught. So in case of LCR circuit, from this equation we can write the current equals to I equals to V over Z, or equals to V, or instead of Z we will be having this very term, that is under root of R square plus XL minus XC whole square. So once the maximum current is in the circuit, at that very time, what we are having, we'll do one thing. We'll first replace XL and XC. We can write down this equation as I equals to V over under root of R square plus XL. We are having L omega minus of, instead of XC we are having 1 over C omega, it will be whole square, because XL is equal to L omega and XC is equal to 1 over C over omega. But we know omega L equals to what? Instead of omega we have 2 pi nu into L, and C omega, that is equal to what? 1 over C omega, that's equal to 1 over C into 2 pi nu. So once you have to remember it once and again, that once the resonance takes place, at that very time definitely these two very terms are equal, that is XL is equal to the XC. Now we have utilized the value of XC, that's L omega, and XC, that is C omega. Now at electrical resonance, at at electrical resonance, as XL is equal to XC, that is L omega equals to 1 over C omega, Just multiplying it, what will become as, which implies it will be omega into omega, it will be omega square is equal to 1 over c into L. Now instead of omega we will give its own value 2 pi nu, that is 2 pi nu whole square is equal to 1 over c L. Yeah, LC, you can write anything. Now we have to calculate this very resonant frequency. Now this nu equals to nu naught. Why nu naught? Nu is equal to nu naught at electrical resonance. So it will be 4 pi square nu naught square is equal to 1 over c into L, or nu naught square equals to 1 over 4 pi L into c, or which implies simply nu naught is equal to 1 by, it is pi square 2 pi under root L into c. This is the expression for what? Resonant frequency, which is the expression for resonant frequency. This resonant frequency is independent upon the resistance in LCR circuit. However, the sharpness of resonance decreases with increase in R. So you have to remember this is an expression which you have to remember. This is the expression for resonant frequency. It is inversely proportional to the root of inductance and capacitance. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.